Today's topic is examining the key features of quadratic equation graphs. And today is May 5th. This is the note packet you'll need for today's lesson. There are 5 pages. I'm also sending a digital copy if you prefer that. The first key feature that's important with a parabola is locating the axis of symmetry. The axis of symmetry is a line that passes through the vertex, which is the lowest point here, and it's parallel to the y-axis. The axis of symmetry does divide the parabola into 2 identical halves. We did examine this when we studied absolute value functions. If you want to locate the axis of symmetry and write the equation for it, we use the equation x equals negative b over 2a. A and b both come from the quadratic equation once it's in standard form. So for an example, we'll use this quadratic equation. This equation does not go with the graph that you see. The value of b is 4 and the value of a is 1. So I'm going to go ahead and sub that in. So we have negative b over 2 times a. So my axis of symmetry is located at negative 2. In the diagram, you can see that the parabola could open up or it could open down. The vertex, which is the turning point, could be the lowest point on the graph or the highest point on the graph. If the graph opens up, like the diagram on the left, the vertex will be the lowest point. So we call that the minimum value or just the minimum. The diagram on the right has the parabola opening downward. So the vertex is actually the highest point on the graph, and we call that the maximum value. We have used our iPad to create a table of values to graph our parabola. What you're going to find is that the vertex is not always present in the table. Sometimes we do need to calculate it by hand. So to find the vertex by hand, we would first calculate the axis of symmetry, which would give us the location of the x coordinate. Once you know the value of x, then you're going to sub the value of x into the quadratic equation so that we can come up with y. And once we know the ordered pair, we will have the location of the vertex. So again, if we go back to this quadratic example, we had already calculated the value of x, which is our axis of symmetry, and we saw that it was negative 2. I'm going to sub this into my quadratic. So f of negative 2, don't forget to sub in with parentheses so that we don't lose a sign. If you do the math on the right-hand side, you'll see that the value is negative 1. So this provides the location of the vertex, which is at negative 2, negative 1. So this is where my graph will stop and change direction. We know that the quadratic can either open up or open down. We will know what happens to the quadratic before we even graph it. So the value of a will determine the direction. If the value of a is positive, then the graph will open up. As a gets larger, it will become taller and thinner. If the value of a is negative, the graph will open down. The same thing is true when a is negative. If it's negative 2 or negative 3, it will become very tall and thin as well. The y-intercept is where our parabola is going to cross the y-axis. You can extract this information from the table of values on the iPad, but what's even easier is when the quadratic equation is in standard form, the y-intercept is represented by the constant. So for this example, our y-intercept would be located at 0, 3. The x-intercepts are where the parabola is going to cross the x-axis. We've been solving for these x-intercepts since we began the factoring process. This will tell me where the roots of the quadratic are. You can also find them on the graph where we cross the x-axis. And remember, they're not always whole numbers or integers. Sometimes they are irrational values. Now, a parabola is a smooth curve. It's not a straight line. On a straight line, we have a constant rate of change, but on the smooth curve, the average rate of change will be different depending on where you measure it. Average rate of change is sometimes abbreviated as AROC. We are going to use the slope formula to calculate our average rate of change. So remember, we use M for slope. We can put AROC to represent average rate of change in Y over change in X. When we calculate the average rate of change on a parabola, an interval will be specified, and we calculate it for whatever they tell us to. So in this example, they want us to find the average rate of change between the interval -2 up to +2, and they are including those values. Using my table of values from my iPad, what this means is I want the ordered pair located at -2 and the ordered pair located at +2. So these are the 2 points that I'm going to use to calculate my average rate of change. So I'm going to sub in. We're starting with a Y value, so I'm starting with 15 minus -1. And then for X in the denominator, we must return to the first ordered pair, so 2 minus -2. Once we sub in and calculate, we can see that the average rate of change is 4. But it's only over that interval. If you expand the interval or shrink the interval, the average rate of change will be different. We're ready to do our first example. So you can see the equation. This is not in standard form. Your iPad will accept this. You could enter it this way. The only issue is we don't know the value of A, B, or C, and we can't extract any information from it. So I'm going to go ahead and distribute and see what this quadratic equation looks like. And up at the top, once I distribute, these are the 4 terms that I get, and the 2 middle terms will simplify. So now we have y equals x squared minus 7x plus 12. I'm going to go ahead and put this into my iPad. You should do the same. Remember, you can pause the video if you want to do it ahead. When I put the graph into the iPad, you can see that it opens up. You can also activate the wrench and look at the table. It will ask you if you want a split screen table, and that's what this is. On the table, we should see a repeating pattern around our turning point. But if you look at my table, there is no turning point. There should be one unique value there. This is a problem. The parabola isn't flat on the bottom. It does have to hit a low point and then go back up. And this is why we have a formula for the axis of symmetry and the vertex. So this was not provided. We need to calculate it. So let's start with the axis of symmetry, which will provide the x coordinate. We're going to use -b. So -7 is +7, and then 2 times a, which is 1. So the x coordinate is at 3.5. Once I know that location, we can calculate the rest of the vertex. We're going to sub 3.5 in for x. We're going to go ahead and do the math on it, and the resulting value for y is -0.25. When you go back and look at the table, you'll see that the iPad does not produce any decimal values. If you look at the graph, we can determine if we have a minimum or a maximum. And because the graph opens up, we know that we have a minimum. The domain represents the interval as you move from left to right. If that parabola keeps expanding as we increase and decrease our x values, we'll realize that the domain runs from negative infinity to positive infinity. There's our graph again. The range. These are the values on the y-axis. We want to start at the lowest point on the graph, which is right here. This is actually my turning point, and it is included in the graph. The turning point starts at negative 0.25, and I did use a bracket to show that it's included on the graph. But as the graph opens up, it will approach positive infinity on the y-axis. Our x-intercepts are where they cross the x-axis, so I can see on the graph at positive 3 and positive 4. I did write them as ordered pairs. The y-intercept isn't present on the diagram. However, if you look at the equation in standard form, the constant is 12, so that tells me that the y-intercept is located at 0, 12. The average rate of change is over the interval of 0 to 3. If I look at the table, my ordered pairs are 0, 12 and 3, 0. So I'm going to go ahead and sub in change in y, 12 minus 0, over change in x, 0 minus, that should be a positive 3 right there. So this will be 12 over negative 3, and my average rate of change then is negative 4. And if you look at the graph between 0 and 3, we can see that the graph is falling, so having a negative rate of change seems appropriate. Let's try example number 2. It's already in standard form. So I'm going to go ahead and put this into my iPad so I can see the graph. When I graph it, I can see that the parabola does open up. And you'll also see that on my graph, I'm looking for the repeating pattern. 1, negative 9 is unique, and then I can see the repeating from the negative 8s and the negative 5s and the 0s. So that tells me 1, negative 9 is my turning point. We're going to go through and identify our key features then. So if we were to calculate by hand, the axis of symmetry would be negative b over 2 times a. So the axis of symmetry is located at 1. If I sub that into my quadratic, it tells me that the output value is negative 9, and the vertex is located at 1, negative 9. The table for this example did show that point because it's not a decimal. The domain. Do we have a minimum or a maximum on this graph? Well, because it opens up, we're going to have a minimum. And the domain runs from negative infinity to positive infinity. In fact, for most parabolas, the domain will always be the same. The range, we're traveling along the y-axis. We begin graphing at negative 9, and that is included. And as the graph opens up, we are headed towards positive infinity. So don't forget your bracket to show that negative 9 is included. The x-intercepts are present on the graph. In my diagram, they're counting in units of 2. So I have negative 2, 0 and 4, 0. They're also present on the table. There's one intercept and there's the other. The y-intercept is present in the equation, so I know that it's at negative 8. The average rate of change is going to be between 0 and 3. So we're using the ordered pair at 0, negative 8, and 3, negative 5. So I'm going to go ahead and use my average rate of change formula. So we have negative 8 minus negative 5 over 0 minus 3. When I finish up with the math, I have negative 3 over negative 3. So I have an average rate of change of 1 in that section. Your homework is number 110. It says key features at the top. There is a back side. There are 4 problems. Make sure you answer parts 1 through 4 for each problem. If you have any questions on this assignment, please make sure you contact me. Have a great day.